Okay, here's the video for Unit 1, Lesson 3, Part 2, Piecewise Functions. I will be able to graph all 12 basic functions, analyze them, create new functions from them through the use of piecewise functions. So we've already been looking at the 12 basic functions, so now we're going to look at piecewise functions using those 12 functions. All right, so what is a continuous function? Well, before we said it's a function that I can draw from left to right without lifting my pen, but now we know that what would break that up is no, and let's actually add in vertical because that seems to be a little confusing. Vertical asymptotes, because horizontal asymptotes don't affect the continuity. So no vertical asymptotes, holes, or gaps. So what's a piecewise function then? It's a function defined by multiple subfunctions. So let's just jump in here. So this is what a piecewise function looks like. It's telling you that part of it, and it always tells you from where to where on the x values, looks like this function, and then the other x values look like this function. So it's kind of nice if you have a pencil and a pen to do these with, to use the pencil to draw in the whole function and then use the pen to darken the parts where we are including the function in our piecewise function. So if I draw, and I'm going to use gray to draw with a pencil, x minus 3. Well, that's just a linear equation. It goes through the y-intercept at -3, and then we are going up 1 over 1. And so this function looks like this. And then I have the x squared function, which we've been practicing. Is from right there. These would be my anchor points. To back up, actually, let me just finish drawing this. Looks like this, kind of. This is also the function x that just goes through here, move down 3 spots. All right, so that's just what I would have in pencil. Now I'm going to trace over it the part that is actually my function. So now I'm talking about the x's that are less than or equal to 0. So that would be right here, and I would want to draw a solid dot and go like this. And then the x's that are greater than or equal to 0, well, to make sure that this is a function, this would have to be a circle. Okay, so at x equals 0, we're actually down here. And then here's the rest of our function, just like that. Okay, I'm going to erase the pencil marks so that way we can see what this looks like. But this piecewise function then looks just like this. Okay, so coming down here, we have the x squared plus 2. So we know that it's just the x squared function moved up 2 spots to right there. And now my other point would be there, and another point would be there. And I'm drawing this in gray again to represent doing this in a pencil. Just like that. And now we need to plot this one, and then using these figure out what part to draw over with a pen. Okay, so my e to the power of x, well, that's just the exponential function. This is just like when we had the exponential function looks like this. So f of x equals b to the power of x. So our base is e. So recall that some anchor points would be, well, if I put in 0, e to the power of 0 is still 1, and then 1 plus 1 is 2. So one anchor point would be 0, 2. And then another anchor point, well, now I'm going to try 1. So if I put 1 in here, I have e to the power of 1. Well, e, rounded off, is 2.7. So I'm going to say 2.7 to the power of 1 is still 2.7, plus 1 is 3.7. So there we go. And then we know that it goes like this. So let's go to 0, 2, and put a dot. Let's go to 1, 3.7. I'm going to call that right about there. And then we're going to draw this in. Okay, knowing that it has a horizontal asymptote typically here, we're going to move that horizontal asymptote up so that it is approaching to right about there. But in a moment it won't matter. Okay, so now let's actually darken in with a different color the parts that we need. So x is less than 0 is our parabola. So up into where x is 0, which is right here, is my parabola. So like that. And then x is greater than 0. Well, now we can actually fill in this hole, because where x is greater than 0, we also start here, and then we follow this guy up like that. So it looks kind of similar to what we had before, maybe just a slightly steeper incline on the left there. One more together, and then I'll have you do the last one on your own. But I'm just going to draw in 1 over x in gray here. So 1 over x has the anchor point here, and then we know that it is approaching y equals 0, and it's approaching x equals 0, so we kind of want to make it look like it's doing that. Same deal over here. And then we have f of x equals 4. Well, that would just be a horizontal line at 4. Okay, now let's read what's actually saying here. So it's saying this one is the case when x is not equal to 2. So where x is equal to right about here, this is the only place where we're not going to use this function. So we'll put a hole here, and then we can trace the rest of it. Just like that, and just like that. Also this one, because it's the whole function except for where x equals 2. Now, where x does equal 2, we're at 4. So there we go. Now, this one might have been a little bit easier if you didn't draw in the 2. You could have just taken the shortcut probably and saw, okay, well, it's the whole thing except for where x equals 2, and where x equals 2, we just have the point 4. But just want to show you that strategy can work for any one of these piecewise functions. So now I can get rid of the rest of it, and there we go. There's our function. All right. This last one, I didn't type it on here, but this is going to be a for you to try problem. You can use the strategy I just showed you by drawing in each of these and then just going over it. Or if you want to piece it up right away, that's up to you. All right, thanks for watching.